And yeah, so there's 5 of them. So I think let's get started with why should you care about the solid principles? What are they and why are they useful? Um, so the solid principles, first of all, if you follow the solid principles, it will make your code better. So I think for the most part, we all know that, there's functional code and then there's good code. You can have code that works, but it's still not very good because it's not very modular, it's buggy, hard to read, unorganized, that kind of thing. So the solid principles will take your code to the next level from maybe being more code monkey-ish to high quality. In addition, it's easier for you to work on because if you write your code good, you shouldn't have to work on it as much. In addition, it's your responsibility. I'm assuming that for the most part, we're all gainfully employed as software engineers or something to do with programming. So if you're getting paid for it, it's nice to know how to write it really well. So I would say that programming is much more of a craft or an art than, say, I don't know, truck driving. I don't know. There's definitely ways that you can do it better, even if you're already, able to code. So first of all, the solid principles are principles. They're not rules. There's exceptions to all of these principles. They're more like guidelines telling you the better way to write code than how you would if you just didn't think about it. So, all right. So for each of the principles, I'm going to start off with a hypothetical question that I'm going to answer by using the solid principle that it corresponds to. So let's get started with the first solid principle. So the first solid principle, the question is, how many functions should a class have? This is obviously a spectrum where on the one hand, you can have classes that have a ton of functions. And on the other side of the spectrum, you can have classes that maybe only have one function each. I would say that neither of these are particularly helpful, although one happens much more frequently than the other, which is the large classes, which I'm going to talk about in a minute. So the first principle is the single responsibility principle, and it has to do with how you group your functions within classes. Basically, the single responsibility principle says that each class should have a single responsibility. That is, it does one thing. So your classes should be divided up in such a way that each class is responsible for one thing. So split your classes up by roles, basically. So I have a meme that kind of illustrates this. It says, just because you can doesn't mean you should. And it has a picture of a pocket knife, which is ironic because it's very big. There's many tools. It probably would not fit in your pocket, and it wouldn't fit in your hand very well. And it has so many tools that if you closed all the tools inside, you would probably have a very difficult time finding the tool that you need. This is a perfect analogy for what happens to our classes sometimes. They become very, very bulky and unusable, I would say. So you want to avoid that. I think what happens a lot of times is people, let's say you're a programmer and you're tasked with adding some new functions to something or other, some application. You might just be lazy and say, okay, well, I'm just going to add these functions right here where all the other functions are in this really big class. And so that just kind of makes the problem worse. So if you're ever tasked with adding some new functionality, consider putting it in a new class where it will not make a class very bulky. So as an example of what this means by code should be separated if it changes for different reasons, it should be combined if it changes for the same reason. What it means by reason is, I like to think of like a Jira ticket, like a task in Jira, or maybe someone who, like a product manager, tells you that some change needs to be done. That's what it means by reason for change. So when it's saying that code should be separated if it changes for different reasons, and it should be combined if it changes for the same reason. Think about, so here's an example. Imagine you work for like a pizza company, like a pizza shop maybe, and they make pizzas and deliver pizzas and all that good stuff that pizza companies do. And you're the developer working on their application, and let's say there's two people at the company that are very interested in your application. One of them is much more interested in pizza delivery related stuff, and the other person cares much more about user information, marketing, discounts, that kind of thing. So what this is saying is that part of the app is going to be helpful to that guy, and another part of the app might be helpful to that guy. But the idea is you want to keep the stuff that they care about separate, because if he asks for a change and I try to make the change by modifying some class that has stuff he cares about in, I risk breaking his stuff and he's not going to know why it just randomly broke. So you want to avoid mixing people's code together. So for each role, you should more separate people's functionality. So in answer to the question that I asked at the beginning, how many functions should a class have? It really depends, obviously, but it should be done. Your classes should be split based on the role that they serve in the application. So each class should do one thing, basically. So as promised, I have code examples. This is pseudocode. It's not any specific language. It looks a lot like Java or C#, but it's really just to demonstrate the logic behind each of these principles. So for this example, I did like a pizza order service, and you can see it has 3 functions, and one of them doesn't really match very well with the class, because you can see that there's 2 that have more to do with pizza delivery and whatnot, and then the third is more to do with customer information. So one way that you can tell that it doesn't really match is by the name of the method doesn't match the name of the class at all. As well, it's the odd man out when it comes to the object that it's taking as its parameter. Neither of those by themselves, I would say, mean that it should be split, but they're more like hints and clues as to maybe this is functionality that should be split into multiple classes, which is what I've done. The real reason that this should be split is because a person cares about the one and another person cares about the other. That's the real reason they should be split, because it's stuff that will change for different reasons, so it should be split apart. So this is a violation of the single responsibility principle. This is not. And I have a little hint that I like to follow when I write code, which is classes should be named accurately, descriptively, and clearly, and functions that don't seem to match the name of the class probably don't match the class. And that's just a hint. It's a principle, not a rule. So it's definitely up to your judgment, but this is what the rule or the principle is and the logic behind it. Okay, so this is the first stop for questions. If anything needs re-explained or explained better, what do y'all think?
Looks good to me.
Sounds good. It's pretty straightforward. These aren't particularly complicated for the most part. They're common sense things that we never think about, I would say. Okay, so I guess we can move on to the next principle then, which is.
So, Daniel, just hold on for a second. So when you say it, like different people care about different parts of the code, I mean, just to kind of map that to what we might see in a computer software kind of world. So if you have an e-commerce application, for example, there are like different categories, right? There's like products, there are customers, there are orders, there are payment methods, payments. So there are a lot of different things. And in a big company, like people who care about finance for example, the finance and accounting departments, they care about certain things, right? They care about the payments and they care about the um, um, some of the inventory and things like that. And then people who care about the customer service people or that side cares about the customers and the orders status, and the inventory people probably have a, like the operations people have a different concern. So when you so I think that's what you mean, right? Like when
Yep.
different people care about different things, it's not from a developer side, it's more from the business side, from the all the users of the software, like
Right.
who cares from that perspective.
Yeah. It basically keeps your code from becoming intermingled, where financial stuff is mixed in with inventory stuff. And if you ever get in a situation where your financial stuff and your inventory stuff is combined, you risk breaking one to work on another, or just
Right.
joining them together in a, and it's not organized is what it is. It's not like there's really no reason those should be together. So
Yeah, I think it like when you're trying to write some code, when you're doing like a customer object, for example, and customer service, it's easy to say, hey, I'm doing this here. Why don't I just update the um, some payment method while I am in the customer service? Why don't I just update the payment method from this class, because it's easy to do. I'm right here. I can just do it. But then what is like, then when you are trying to change the payment method, you want to enhance that class, suddenly your code breaks because something is happening somewhere else that the code doesn't, the people who maintain the payment methods service don't understand why this code is not compiling anymore or not working, because there is a dependency that's changing somewhere else. So
yeah, I didn't even think about that one, but that's very valid. Well, on top of that, your classes become really big if you join things together unnecessarily. So
right. So it may seem easier now, but when you go into the maintenance mode and enhancement mode, like that's where this really comes into makes it easier and comes into play.
yeah.
All right, thank you.
Anyways, anything else before I move on to the next principle? I think that'll probably do it. All right. So when should you have to modify working code? Well, this does happen all the time, but this is what our next principle talks about. When is it better or worse to modify working code? So I have an example kind of drawn down here below of code that works. You have a utility class and a class that uses the utility class. This is a paradigm that I will refer back to a few times. So the open-closed principle, it's basically saying that your code should be open to extension and closed to modification. So there's two things involved with this. When it says open to extension, it means literally extending the class. And by closed to modification, it means that it's dangerous to modify working code. So I'm going to explain that in a second. So our meme is open chest surgery isn't needed when putting on a coat, which is true, open close principle. Yeah, so you shouldn't have to work on old code to add new stuff. Definitely sometimes we do work on old code, but this principle will show you why it's better not to. Unless you have to, of course. So when you modify a class, it can introduce breaking changes to any code that uses that class. So when you have some code and it starts to break on you, it's easy to think that the code has a mind of its own and it's alive, but pretty much it's guaranteed that the reason it stopped working is because something changed and someone changed it. So basically, when a piece of code works and it has 0 bugs, modifications to that class can only make it worse, right? It's a little bit like when it comes to cars, when you drive onto the road, you are introducing the roadway to a certain amount of risk, which is yourself, your car, and anyone that you come in contact to is in more danger because you're there than if you stayed home. So it's the same thing as that. When you modify working code, you are putting the integrity of the code in jeopardy. So modify code at your own peril carefully. Inversely, extending a class never breaks anything because the extension is not used by anything yet. So when you have a class, and let's say this is an old class, it's been around for a year, 2 years, whatever, you got 3 or 4 other classes that use the functionality in this utility maybe, right? So if you went and modify this class, you don't know how other classes use it, so you could potentially break this. But if you extend it, this new piece of code is not used by anything yet. So it's as if you copied all the stuff from here and created a new class and then added to it. So this is also safe. So extending a class is much safer than modifying old code. So that's what the open close principle is about. And so I'm kind of demonstrating what I just told you, which is this, this working code here on the left. It's a utility class. Some class is using this utility class. Me as a developer, I have to add some new advanced utilities to this so that I can do some advanced stuff. The open close principle is about saying that it's better to extend the utility class and create an advanced utility class than it would be for me to just add those advanced utilities directly into the old utility class. So when should you have to modify working code? The answer is you shouldn't have to. You know, obviously it's not a rule, it's a principle. Sometimes you do have to work on old code, but this principle goes to show that it's better not to. Just extend your class or use interfaces to create a different version, which is another way to use the open close principle. So where does this apply? This applies mostly to classes that you expect to reuse, like your utility classes. And this is true. So for example, your controller, if you're making an app, like you have a controller, that's only for the most part going to be used once. So if you extend that class and add some new functions, and then, well, that extension isn't helping you much unless something's using it, right? So you're pretty much going to have to swap it in there and put the advanced, and then the old one's not doing it. So there's really no point in extending a controller is the point I'm trying to make. So it's for things that you expect to be used multiple times throughout your app, like your utilities or your services. All right. So how do we do this in real life? Let's look at some code examples of what this looks like. It's really simple, very easy paradigm to follow. We all know how extension works. You have a service or a pizza order service, right? It has a function. You extend it to add another function. Super simple. This is the old way to do the open close principle correctly. There's another way, which is by using interfaces. So let's say pizza order service is an old thing that has been around for a long time. It's already being used. Instead of modifying pizza order service, you can just create another implementation of its interface. So sushi order service, that's a new thing, and the code in it can be slightly different. So if you have to make a modification, sometimes it can be helpful to just create another implementation of the interface. And additionally, you can extend that interface instead of modifying the interface. So by doing this, you can extend the behavior of a class that implements the interface by even adding more functions. So this is the open close principle. All of these are technically correct. There's no problems with any of those. So is there any questions about what I just talked about? Okay. Well, I guess we can kind of move on to the next thing. So let's say you have a hierarchy of classes. When is it acceptable to override a super method of a parent? This one's fun because for the most part, I feel like none of us have really thought of when you should or shouldn't override a super method. We just do it, right? Um, there actually is some ramifications of overriding super methods, and that's what this principle talks about. So the Liskov substitution principle, named after Barbara Liskov, who is, I don't know, an IT researcher, I guess, programming researcher. She basically says that when you have a hierarchy of classes, you shouldn't have to modify the parent class with a subclass. You shouldn't override super methods in a way that changes how an application works. So the meme is, if it looks like a duck and quacks like a duck but needs batteries, you probably have the wrong abstraction. And what this means is, if you have a class, which is a duck, and then you extend it, but for some reason the child requires batteries, it's almost like they're not even related. So if you're modifying all the methods from the parent that it inherited anyway, it's almost like, why would you even extend it if you're just going to change it? So it's like it's two different classes. So it doesn't make sense in that regard. So basically, the Liskov substitution principle says that when you are extending a class, so you have a class, you extend it, the child class, the subtype, should be able to be used interchangeably with the parent as far as any of the things consuming it are concerned. So there's a very good reason for this, and I'll explain it. It should be pretty clear after this. Say you have a hierarchy of classes because you've been extending the functionality, perhaps. So if you violate the Liskov substitution principle in this case, for example, and your food order overrides a bunch of methods from order, and food delivery order overrides methods from food order, it gets to the point where all of these do different things or do the same thing kind of differently, and it's not very clear how they're related. So some programmer who comes to the company after you, and they have to use this, they're going to look at this and say, wow, which one do I need to use? They might know that they need to use one of them, and they'll try each one, and maybe none of them even work exactly how he needs it to. It would be much more logical and easy to use if each of these was adding incrementally additional features, not modifying its parents. Because then all he needs to know is, what's the minimum amount of functionality I need in order to do what I'm trying to do. So basically, Barbara Liskov claims that extension classes should be incremental additions of functionality, not modifications. So avoid overriding super methods if you can, but it is a principle, not a rule, and there are exceptions. So one example of a place that you could override a super method is, let's say you have a database service and it does all the CRUD stuff, creating, reading, updating, deleting, all that. You can extend that class and name it something like DB service with logs. And then you can override all the super methods and just add logs all throughout. So the point is, it's not about the lines of code being unchanged. It's about how the app functions as far as consumers are concerned. And, making your hierarchies of classes logical too, I suppose. So what does this look like in real life? Code examples. So you have a class to draw red line service, and maybe this is some drawing application, for example, like Paint. It has a function to draw a line, and then you extend it with draw a red line with green ink service, and its method overrides the parent. So notice in the name it says draw red line with green ink. Well, that'll give you a green line. So that is a change in how the app functions based on which one of them you use. So this is wrong. This is a violation of the Liskov substitution principle. The proper way to do it would be to have your extension say draw red line and green line service. So this is only adding a function. It's not modifying its parent. It's not overriding the super method. So this is how to, that's monkey, that's Barbara Liskov. Be like Barbara Liskov, don't be like a monkey. So that's how to do the Liskov substitution principle. Are there any questions about that?
Yes, Daniel, this is Todd. I've got a quick question. Can you go back to the previous code example?
Yes, we can.
So here, because this is extending, how crazy is it to add a draw red line function in the extended service that just calls draw line in the super?
Well, since it's extending, it already does have that function, so it can do both. So I guess the bottom example right here, the far bottom, it can do draw green line and draw regular line. Actually, can you guys see my pointer?
Yeah, we can see it.
Oh, okay.
Right. And so I understand that. I just thought, maybe I want to make it explicit here because of the naming of the function.
Yes, you're actually right. I would rename this function. I wouldn't leave it as draw line. I would change it to draw red line. That's a good point.
So you would leave the function contents intact, but you would actually modify the superclass here and just with the rename.
Yeah, I would probably rename it.
Okay.
Yeah, I think that's a common pattern. You just do a draw red line and then do super dot draw line, right? So
yeah.
So that way, like, you're not rewriting the draw red line function, but you're presenting a more uniform interface out of your extended class.
That's a very good point. Interesting stuff. I love it. I love it. All right. Well, I guess we can move on to the next principle. So, when is a massive interface helpful? Well, I feel like if you've been programming for a while, you know when an interface is not helpful, and that's what this principle is about. This is called the interface segregation principle. So basically, this is about splitting up your interfaces in a logical way. So the meme we have here is you want me to plug this in where, and the point is that the interface is so big that it's become unuseful. Nobody knows how to use it because it's too large. So you don't need one interface to rule them all. Split your interfaces up. It's better to use 3 small interfaces than one big one. So think about it this way. When you make an interface, the whole point in making an interface is for it to be implemented by someone else. So when you create a class and you create an interface for that class, there's no point in having the interface until you have at least 2 classes using that interface. That's the whole benefit of it. It allows you to use one or the other. So think about when you're making an interface, think about trying to get your coworkers to use that interface for their class. So you don't want to make an interface that's so big that it is unusable. And I feel like we've all kind of dealt with this, where you have some interface that for some reason, maybe you're unit testing and you have to implement an interface for a mock, and it's got 105 functions and you really only need to use 3. So that's not ideal. It's better to have your interfaces be smaller and more usable. All right, so it's a good idea to make sure your interfaces follow the single responsibility principle too. Yeah, so when you make an interface, that's basically a contract saying that my class, basically an interface is a contract saying that your class will use all of those methods. And that's not always helpful if you're if you're forced to use a interface that forces you to make the class violate this single responsibility principle, that's not useful. So make your interface split up by roles as well. Similar concept to the single responsibility principle. Another quick note is you should use the open-close principle on your interfaces as well. So in the example that I had in the previous principle of the open-closed, I've kind of extended that a little bit by saying, okay, you got an interface that's an old interface. It's being implemented by multiple classes, perhaps. Rather than saying, okay, I want to add these functions to that interface, keep in mind that if you do that, you're going to have to also add those methods to all of the implementing classes. So instead of doing that, you are able to extend the interface, and then you can add any new functions you need into the extended interface. That keeps you from adding stubbed out methods to a bunch of classes that implement some interface you changed. So yeah, so pretty useful to do that. So as an example of splitting up interfaces, take this notification service. It implements iNotification service. This seems to make sense. This is probably a class I would make if I wasn't thinking very carefully. The issue with this is that, so let's say I make this class, I make this interface. If some person at the company 3 months later decides that they need to have a way of sending emails that is different than how I've done it already, then they're going to have to implement this interface, and that's not helpful because that means they also have to implement texting. So you see where I'm going with this, where like they only need to implement email, but they're forced to implement text because that's what my interface calls for. It calls for them to implement both when they don't need to. So you want to split your interfaces up so that depending on what a programmer is trying to do, they don't have to implement stuff that they don't need. An interface should have everything that they need and nothing that they don't. So also, I suppose it's worth noting that this is kind of a code smell because your class is doing multiple things here. Notice you're implementing multiple interfaces because you're doing more than one thing. So it's probably at least a possibility that you want to split this class into multiple classes. They are kind of related though, so it's hard to say. Again, it's not a rule, it's a principle. It's for you to decide using this thought process. So this is a violation of the interface segregation principle. This is what you want to do. So are there any questions about that?
Yeah, I think what you said makes, yeah, it's because at least with languages like Java, when you implement an interface, you then also have to like provide at least like a empty function for all the methods in it. And so like even when you're trying to create a mock or object or something or a stub service, then you're pretty much rewriting a lot of stuff over and over again. And if you want to change the email provider, like the way you do text, for example, if you are switching from one provider to a different provider, then now you have your code spread out in multiple places where you have to go and pull that out and change it, and you are likely to miss it. So yeah, so I think to me that's the most valuable part of it, is separating out the interfaces. And you can make super interfaces too, right? So you can make one interface that implements, like you can have a notification service interface that implements different notification types if you need to, but you don't start there, you rather end up there.
Yeah, that's very interesting. Yes. Cool. So if that makes sense to everyone, we can move on to, I believe, the last principle. Yep, D comes after I, so that's the last one. Okay, so when is concretion better than abstraction? Abstraction is just another strange word for interfaces, and concretion is just another strange word for class. When is it better to not use an interface, in other words? So the final principle talks about that. It's called the dependency inversion principle, not to be confused with the dependency injection principle, which is related, so I'm probably going to explain that as well. So basically, this principle says that you should use interfaces. Depend on interfaces, not concretions. It doesn't say use them, it says depend on them. So our meme is, let's see, would you solder a lamp directly into the electrical wiring in a wall? I think this is a perfect analogy because sometimes we do solder lamps, like ceiling lamps. Those are attached directly to the wall. But of course, we have other lamps that have plugs that we plug into outlets. And the difference between those types of lamps is, one, we expect to possibly replace. The other is, somewhat more permanent. So that's pretty much exactly the way to think about using interfaces in your applications. So instead of hard-coding implementation details in your class, use an interface so that high-level classes are able to swap out functionality. So think about this. Let's say you add a Mongo database service to your app, and it's a big file. Maybe it's like 500 lines long, okay? It's a big class. And the next day, maybe your boss or somebody comes to you and says, hey, we don't want to use Mongo database anymore. We, for financial reasons, have decided to switch to Postgres. So you're forced to go back over that 500-line file, remove any reference to Mongo, and replace it with Postgres. This is a lot more complicated than it has to be if you design it properly in the first place by using interfaces. So when we have apps, we have many services, and those services fall within categories of services, I would say. So at the top is what I would call a category of service, like data access and notifications. Mongo database, that's a very specific service. It's a type of data access. So the idea is, when you're making your application, you want to have an interface for the categories of services that you have. So for example, if instead of using Mongo database, you used an interface called IDB service, then wherever you use that, it doesn't really care the exact implementation details. You've abstracted out implementation details. So when is concretion better than an abstraction? It's the exact same as with the lamp example that I told you. A ceiling lamp connects directly to the ceiling, and it's because we don't expect to modify it, or perhaps we expect to never modify it. So when you know that a piece of code will never change, it is acceptable to use a concretion. So for example, a controller, maybe, because again, you're not going to be extending your controller. You're not going to be doing a whole lot to your controller as far as swapping it out for a different controller. That would be strange. I will say that if you're doing unit tests, which, if you're not, I recommend that you do unit test your controller. But if you're not doing unit tests, then you don't really need an interface for your controller. So that's useful, I would suppose. But yeah, with your utilities and your services, it is helpful to have interfaces for those. That way you can swap them out if you have to. So this is a code example. So all right, so let me explain dependency injection for you. Dependency injection is when you're injecting the services that you use. So in this code example, we have customer info service, and it has a variable for MongoDB service, but it's not instantiated in this class. Underneath it, we have a constructor right here, and this is expecting the MongoDB service to be injected in, and then we just set it as the variable. And then throughout our object, we kind of use it like we had instantiated it. So basically, your main method or whatever is above this class instantiates both this class and the services used in this class, and it injects them in through either a constructor or a setter or something like that. That's called dependency injection. Dependency inversion looks similar, but slightly different. So the code on the left, I've copied to the bottom of the code on the right. The only thing that I changed was, instead of saying MongoDB service, I'm saying IDB service, and that's because it's using an interface now instead of a concretion. It's an example of what using an abstraction instead of a concretion looks like. So the constructor, it's not expecting MongoDB service, it's just expecting some implementation of that interface. So this interface, IDB service, has maybe all the functions that you would need to use with a database service. And then you have a class MongoDB service. It implements that interface. But you could also implement the same interface with your PostgreSDB service. So basically what this is saying is customer info service doesn't care whether it's using Mongo or Postgres. As far as it's concerned, they're both the same. As long as you implement the code for them differently to use Mongo versus Postgres, it should work the same way as far as this is concerned. So in your main method right here, notice it's instantiating the customer info service, and then it's also instantiating MongoDB service and injecting it in. But it could just as easily instantiate PostgreSDB service and inject that in. It makes this very modular and easy to switch up if you have to. Okay. So the one on the left, it does not use dependency inversion or abstractions. The one on the right does. That is the benefit of it. All right. So does anybody have any questions about that?
Yeah, that dependency inversion, that's more about just when you make a code change that you have less places to make the change in a way.
Yes, I would say yes. Because then you don't have to touch working code is the magic of it, because this is untouched even if you have to switch the database. So if this worked for MongoDB, it should work for PostgreSDB, basically. And so it saves you a lot of time when it comes to switching out dependencies. Another interesting detail is you can switch out your dependencies programmatically. If you wanted to have an environment variable that says, use Postgres or use Mongo, and you wanted that to actually work, where if the environment variable says Postgres, use Postgres, they call that strategy patterns. And basically that's where you can switch the dependencies programmatically using variables or environment variables or runtime variables.
Yeah, I would say that swapping out the backend database is not a very common thing, right? So, but another place where it really helps is if you are trying to unit test this service, for example, and or you have this service and the service is a dependency to the controller, then you don't, and if you want to write an integration test that goes across the controller and the service, then you can just have a mock DB service that you can swap out, and you can inject the mock DB into the into your test class and like have it pretend to be a database when it's not, right? So both for unit testing and integration testing, it can be very helpful to do dependency inversion, because that way you're not having an actual concrete class that you have that you cannot test anymore. You don't have to attach a database to unit test your service. So that's also a very useful reason why you would want to do something like this.
Yeah, that's silly. Yeah, of course, I didn't mention that the main advantage of this is you can actually unit test properly. But that is the main advantage, is you can properly unit test. But on top of that, it makes your services more modular.
All right.
All right, well, okay, so that's all of the solid principles. And this has been the solid principles for monkeys. I definitely thank you all for coming out. Well, I guess you didn't come anywhere, but but yeah, I just want to do a quick review. It's important to note, though, that the solid principles, you will get the most benefit from them if you actually research them on your own. The fact of the matter is we don't usually take time to stop and think about these kinds of deep architectural questions. You want it to be somewhat automatic, kind of an instinctive reaction to certain things. So definitely consider researching them on your own. All right, time for a supersonic 2-minute speed review. Let's see if I can do that. Okay, so the main benefits are that your code will be better if you follow the solid principles. And I feel like the people here care whether their code is better. It'll make your life easier because it'll be easier code to work on. You're getting paid for it, probably. So you might as well learn how to do it well. And so the principles themselves, single responsibility principle, you want to separate things that change for different reasons and join them if they change for the same reason. Open close principle, open for extension, literally extension or possibly interfaces. Closed for modification. You want to avoid modifying working code if possible. The Liskov substitution principle, when you have hierarchies of class, you don't want to change how your parent functions are doing things. So only use super method overriding when there's something minor that you can change that won't change how the app works. Interface segregation principle, split your interfaces up into smaller, more usable chunks. Interfaces are meant to be implemented, so make them implementable. Dependency inversion principle. This is about using interfaces. Use interfaces for each of your service classes. That way they can be swapped out if necessary, especially in the use case of unit testing. Okay, thank you all. Congratulations, you're a new solid practitioner certified by the Daniel J. Dixon School for Monkeys. All right. So do we normally do like discussion at the end or what?
Yeah, we definitely have time. So if people have any questions, please feel, or points or any comments that you want to make, please feel to jump in here.
I'll ask one. This was good, but how should we get the slide deck? Or how could we get the slide deck? Or could we?
I'll get it from Daniel, and I'll post it on the meetup site, on the meetup event, as a comment or something.
Sounds good. Thank you.
Okay, we're actually getting text messages, it looks like.
So we have some chat questions. So I'll ask you those questions. So first one was, are you going to cover technical debt?
Yeah, I'm guessing this is in reference to the open-closed principle. Yes, you still do want to clear up technical debt, and that is one of the examples of a place that you could modify working code. Just do it carefully. Basically, the principles still apply. If you have to modify working code, then so be it. It's just better to avoid it. That's why the principle is called closed for modification.
Right. And I would further add that in my personal experience, um, I like to address technical debt as I'm going along rather than as a separate activity. So if I'm going and changing something somewhere or adding some functionality or deleting functionality, I take a moment to kind of observe what the design is, and if there is a chance to apply these principles, I would rather do it as part of the feature work rather than try to have a huge technical debt backlog and try to like do them as separate stories. So yeah, that's a great opportunity to kind of think through and see if you can apply some of these principles when you're looking at old when you're tackling technical debt.
Yeah.
All right, the next question is how to handle the arbitrary increase in complexity as you add more relationships among classes.
Arbitrary increase in complexity as you add more relationships. I'm guessing this has to do with the Liskov substitution principle, where you have hierarchies. I'm not sure what the best way to handle the increase in complexity is. I just know that it's better to avoid overriding super methods when possible. If you do have to override a super method, but maybe it's just one function, it could be that this is not even the same class. Think about it as copying all the contents of a class and then adding one more. That's the use case of extending. If it's not like that, then it might just be a different class on its own, right? It doesn't have to extend the old class. If it's different, then it's not an extension.
Yeah, and I would add that, and Daniel mentioned this several times. It's like these are not like like rules, right? These are guidelines, and sometimes you have to make judgment calls on how you organize your classes. One thing I always say is don't be afraid to change your classes around, right? So as the software evolves, as your business evolves, you are learning more about what your software should do, and part of that might be like going back and changing things that don't make sense anymore. So one way of dealing with complexity is just like taking a step back and looking at the overall design and say, hey, are there things we could reorganize? Are there things we could combine? Are there things we could decompose? And are there things we could eliminate completely? So yeah, it's more of an evolution. It's not a one-time activity that you do. So yeah, there definitely will be some increase in the amount of code that is created as part of this, but it's more about, does it make sense? Does it make it easier to change and debug? So that's where you want to think about. That's what you want to think about. All right. Okay, I'll go on to the next one. Any insight for keeping interfaces local to the project versus installing with package manager?
I feel like it's probably better to keep them local, but that's only if you don't have control over how they're made, because it's happened to me before where I install some sort of package or plugin and it's some complicated service and the interface for it is impossible to use. This has happened to me. If it comes with the package, then use it. But if it's in your control, then follow the interface segregation principle.
Yeah, that's that's a good point raised by Robbie here. Yeah, if you have to use an external library or a framework or something, and they already have an interface, then yeah, there's usually not a good way to deal with it in languages like Java. If you program in Go, for example, you don't you can write your own interface, and the class will still implement that interface intrinsically. But yeah, with Java or I'm assuming with C Sharp, that can be a problem. There are some ways of doing it, like with wrapper interfaces and then applying some of the other design principles from Gang of Four design principles, but sometimes that's not really worth that hassle. So yeah, it's probably a choice you have to make depending on how complex that stuff is. All right, so that's all the questions on the chat. Anybody else have any questions? Any general comments? All right. Looks like we don't have any more questions. All right. Thank you very much, Daniel. This was great. Great to see the examples and also like, talking through some real life scenarios. I think that's really valuable. A lot of times when people think about solid design or design principles, they're just seems like a lot of words that they cannot relate to. So thank you for making this presentation so useful.
You're welcome.
And I'll reach out to you about sharing the slides later.
Sure.
This is also being recorded. So once we have the video and once I get working on the YouTube channel, we'll get it uploaded as well. So
Oh, that's awesome.
yeah, so thank you very much. And I'll stop recording now.